Η κυρία Ιωάννα Δελικιόζη είναι διδάκτορ χημικός μηχανικός και αποφοίτησε από το Εθνικό Μετσόβιο Πολυτεχνείο. Το 2009 απέκτησε μεταπτυχιακό δίπλωμα ειδίκευση στον τομέα της επιστήμης και τεχνολογίας των υλικών. Κατά τη διάρκεια του μεταπτυχιακού της, είχε εμπλακεί στον τομέα των προηγμένων σύνθετων υλικών. Το 2012 υπερασπίστηκε τη διδακτορική της διατριβή στο πεδίο της υπερμοριακής χημείας νανοτεχνολογίας. Σήμερα εργάζεται ως ερευνήτρια στο Εθνικό Κέντρο Έρευνας και Τεχνολογικής Ανάπτυξης και ως επιστημονικό συνεργάτη στο Εθνικό Μετσόβιο Πολυτεχνείο. Έχει συμμετάσχει σε διάφορα ευρωπαϊκά ερευνητικά προγράμματα ως κύρια ερευνήτρια. Είναι ενεργό μέλος της ΑΣΡΕ, γραμματέας και υπεύθυνη της εκπροσώπησης των φοιτητών του ελληνικού παραρτήματος. Κυρία Δελικιόζη.
Hello to all. Ms. Galiotti, thank you very much for your kind introduction. I would like, first of all, to thank the organizers and especially the ASHRAE Hellenic chapter for giving me the opportunity to present a part of our group's work in this conference. The subject of my presentation has the title Multifunctional Facades of Reduced Thickness for Fast and Cost-Effective Retrofitting. This is a brief outline of my talk. To begin with, I would like to say a few words about the funding opportunities that the European Commission provides not only to research institutions and universities, but also to small, medium, and large enterprises. Then I will very quickly jump into the field of energy-efficient buildings that is also in complete alliance with the further purpose of this conference. And then I would like to introduce you in a quite new field that's named nanotechnology. Most of you are probably informed about this. We will see a few new ideas and how we can incorporate these materials in order to improve the building and the building efficiency. Then I would like to speak about a funded European project that will involve these latter two categories, these quite different scientific and technological categories. From one, we will have the building, from other, the building materials, and we try to develop new and innovative solutions in order to be applied in facades. So as far as we all know, and taking into account the bad economical crisis, not only in Greece, but also in whole Europe, the European Commission launched in 2007 a funding instrument in order to fund research and technological development. This funding instrument will be finalized in 2013, where the overall budget has been about 50 billion euros. As most of you recognize it, this funding opportunity will be finalized at the end of the year. Thus, the European Commission set up a new funding tool that will be started in 2014 with further purpose to enhance excellent science, societal challenges, and industrial leadership. The overall budget allocation now for this funding tool will be about 75 billion euros, 25% increased compared to the FP7. As part now of the European Economic Recovery Plan adopted in November 2008, the Commission launched in 2009 three public-private partnerships to tackle the consequences of the global economic downturn. The aim of these three PPPs was to fund research and innovation in three different key industrial areas. The one area has become the manufacturing area that means the factories of future. The second area is the construction area that also involves the activities of the energy efficient buildings. And finally, the automotive area with further purpose to boost competitiveness and support employment, while at the same time significantly contribute towards a more green and sustainable economy. The energy-efficient buildings now provide a financial envelope of about 1 billion euro to enhance the construction sector by investigating method, but not only, also technologies to slash the energy consumption and CO2 emission, not only of new, but also of renovated buildings. The overall budget now derives for the energy efficient buildings derives from the interaction of three different areas: the NMP, nanotechnologies, materials and production technologies; the ICT, information and communication technologies; and finally the energy and environment. Let's say at this point a few things about the construction sector in Europe. It offers about 16.4 million jobs, or 30% of the overall industries. This could be closely translated to 3 million enterprises, 95% of which are small and medium enterprises that generate at about 10% of the European GDP. The buildings use the biggest amount of energy, consumes the biggest amount of the energy in the European, that has been estimated to be at about 40%. The building environment generates 1/3 of the GHG greenhouse gas emission in Europe. And have in mind that also, most of us know, that also the existing buildings are far away from being energy efficient. And in this slide, you see a breakdown of the energy losses. So, especially in the sector of the buildings, we can recognize two different categories: the residential as well as the commercial buildings. The biggest amount of energy losses is attributed to the cooling and heating demand. This is also exactly a part of my presentation. I will explain further details following. Now, the overall vision of the energy efficient buildings is to deliver, implement, and optimize buildings and district concepts that have the technical, economic, and societal potential to drastically decrease energy consumption and reduce CO2 emission of both existing as well as new buildings through the European Union. At this figure, you can see an existing building, and the energy losses from the different parts of the building You can clearly identify that the biggest amount of energy losses, that this is about 35%, are definitely dedicated and attributed to the insufficient insulation. Thus, solutions such new materials could be applied in order to reduce these percentages. The further purpose now, in order to enhance the materials and its properties, is by using new materials. Nanotechnology could be used and contribute in the manipulation of material on an atomic and molecular scale. The nanomaterials has become a rapidly growing field that takes a material science-based approach on nanotechnology. To give you an order of degree, have in mind that 1 nanometer is equal at about 1/1000th of a meter. So the first steps through basic research in the field of nanotechnology started at the beginning of the 70s, where up to then we saw a very rapidly growing, very new market. And even from statistical point of view, the National Science Foundation has predicted that probably this market will reach 1,000 billion euro during the time period 2015 to 20. So the nanomaterials could be divided into two big categories, the nano-objects and the nanostructured materials. In the first case of the nanomaterials, you see three-dimensional particles that are named nanoparticles. The nanofibers that have 2 dimensions in the nanoscale, and the third category is the nanoplates that have 1 dimension in the nanoscale. Yes. So at this slide, you can very quickly see some applications of the nanomaterials that could also be applied in order to enhance the energy efficiency of the buildings, such as renewable energy, environment, electronics, and some industrial applications. So now it comes a very crucial question that probably most of you have. Why do we have to incorporate nanomaterials and nanotechnology into buildings? I believe the answer is quite simple, only taking into account that the construction sector is a 1 trillion industry per year. Thus, we can contribute in order to develop new type of materials to enhance the functions of the material, so it could be probably be effective to lower the operating cost of the buildings. Exactly. By incorporating, as I told you, the nanomaterials into the building, I will present you at this time how we can use the nanomaterials in order to construct facade systems that will apply have multifunctional properties. Under the framework of the MF retrofit project that has been funded by the European Commission for 5,100,000 euros, the consortium attempts to develop a new type of facade system by incorporating nanomaterials. So the main target of the project is to develop lightweight, multifunctional components with high potential of energy savings. Thus, it will be effective to provide very high insulation properties to improve also the mechanical properties by diminishing the time required for the renovation. All the developed things have to be also in completely aligned with the regulations. So in order to develop such a multifunctional material and system, it is clearly seen that a lot of partners had to be involved in this project. The coordinator, the National Technical University of Athens, selected experts in their field that have been spread out in 7 different European countries. Here you can see a detailed design about the facade system that is attempted to be developed. It will be used a 6-layer approach in order to provide different properties to the material. So we will have a 2-layer system in order to have the main insulation layer. Then it will follow another 2-layer system that will provide the structural layer, and finally we will develop an external layer. I will make the breakdown following, so you will see a lot of further details. So the main insulation layers, I told you prior, will have 2 different layers. The one will be the uncorruged layer and the other the insulation layer. The main function of this device will have as further purpose to enhance the mechanical stability, the thermal and acoustic insulation of the overall panel, as well as to be very lightweight. So more specifically, the uncoiled layer will be the foundation of the panel. It will be directly compressed against the outer wall, covering some probable defects and lamps that exist in buildings. Following, it will be introduced the insulation layer that will provide excellent thermal and acoustic insulation, as well as tertiary level of protection of the fire protection of the panel system. More specifically, in the case of the uncoiled layer, there will be developed some polymers. In the market, there exist various polymer-based forms in order to enhance the insulation. The main scope and challenge under the framework of this project is not only to produce polymer-based materials, but produce them from renewable resources. In order to develop this type of polymers, some natural oils will be applied. Thus, the latter material will be quite more environmental friendly compared to the usual products, providing also a very low carbon footprint. So now, in order to enhance the functional properties of the polymeric form, it has been planned to use some nanomaterials. The nanomaterial that will be investigated will be some carbon nanotubes, which dimension lies at about 1 nanometer. The carbon nanotubes will contribute in order to enhance especially the mechanical properties of the layer, taking only into account that they theoretically are 100 times stronger than steel. So by introducing these nanoparticles into the matrix of the polymeric material, and by investigating the different synthesis parameters, it will be effective to construct the first layer. Going now to the insulation layer, the material that will be applied is a quite new class of materials that NASA has started to implement in their application. So the biggest challenge will be to reduce the production cost of these materials. These materials are called aerogels, where the aerogels consists of 96% of air, 2% of clay, and 2% of polymer by volume. Thus, it is essential that they are very lightweight materials, but not only that they are lightweight due to the fact that they have incorporated a lot of air, this also contributes to the good insulation of these materials. So in the market, you can see some layers, some aerogel materials, but the commonly used aerogel materials are silica-based. So a further challenge will be to develop salt gels that will be clay-based. So here you can see some R values of commonly used materials. So our target during the MF retrofit project is to have at least a U value of about 0.2 watts per square meter Kelvin, and also to lower the thermal conductivity of this specific layer to have a value of about 0.012. So the next type of materials that is attempted to be incorporated into the layer of the the developed layer of the aerogels is the nano phase change materials. These materials are, the recent years, a lot of attempts have been, they are very intensively investigated due to the fact that, that they mitigate energy losses by storing and releasing big amounts of energy. So starting from a solid state, they liquefied under specific temperatures. Those they have the ability to absorb heat. Changing the climate, they can also be converted from the liquid phase to the solid phase by releasing this heat. So they can enhance the insulation properties by releasing and storing energy that will furthermore contribute to the insulation. So then we go to the structural layers, where the structural layer will be divided also into different layers, the durable and the external layer. The durable layer has as further function to protect the inside layer from humidity, as well as offer necessary mechanical properties to the panel. After the durable layer, it has to be installed an air gap. The air gap will contribute to the ventilation of the panel in order to control this humidity. Finally, it will also contribute to homogenize the building temperature. After the air gap, it has to be installed. It will be installed the external layer that will provide flame retardancy by also offering the appropriate mechanical properties.
Ms. Deligikiozi, you have 10 more minutes.
Okay, thanks. The durable layer will be now a polymer, not an usual polymer like the organic ones, but it will be a geopolymer. The geopolymers are also a quite new category of materials that could be constructed from alkaline solutions and aluminosilicate sources. Those, during this polymerization reaction, they could be constructed three-dimensional networks that have a very dense, provide a very high density. These materials will provide the appropriate mechanical properties to the panel. So I will go a little bit quicker. So the external layer, in order to construct the external layer, the nanofiber reinforced polymers will be used. These polymers will be based on epoxy retin matrix, and into this matrix it will be essential to incorporate glass or even carbon nanotubes in order to enhance the mechanical properties. Here you can also see structure from an electron microscope. You can see very dense interactions of the fibers. So this is exactly what makes these materials flexible. So going now into the external layer. The external layer will be first of all, we can find the intumescent layer that protects the internal component. It will provide fire protection and the anti-corrosion properties. More specifically, the intumescent layer will have a very specific chemical composition based on latex, in this matrix also some aerogels or even some other nanopowders that are flame retardant that our flame retardant will be incorporated. The further scope now, in order to develop this and enhance this type of materials, is by altering the chemical composition. The purpose is to reduce the temperature that these materials react. So the traditional intumescent layers react when the temperature of the substrate reaches the 250 degrees, and they spread out, they make a foam. So thus, exactly, this is the function that stops the fire. Finally, let's go to the external layer. The external layer will not only be applied for aesthetic use, but also due to we attempt to develop photocatalytic coatings. The main scope of this is to appropriately chemically modify the titania. It is a very well-known material that is used in self-cleaning coatings, and to make them function through a chemical reaction in order to have the ability to degrade various types of pollutants that probably are stuck on the facade. So a very important part of the project will also be the life cycle analysis, where we have to set down all these different materials that have to be developed, and to make appropriate estimations whether this developed facade could be at least cost efficient. So at this slide, I tried to zoom up some parameters, such as that the final product will have, such as, I will not go in details in each category. I believe the most of these I told in each slide. Finally, by implementing nanomaterials, the building of the future, by having advances in various fields. I don't know, Valia, if I'm okay with the...
You have 5 more minutes.
Oh, I have. So some other potential applications of the nanomaterials that are related with the buildings could be the photochromic glasses, fire protection, coatings, solar cells, insulating aerogels, organic light emitting diodes, or even structural beams. Thank you very much.